Okay, so today we'll do chemistry 2.1. Let's get to the thingy. Probably should hit pause first. As per common practice, we go to the syllabus and we copy out exactly what it says. Name appropriate apparatus for the measurement of time, temperature, mass, and volume, including burettes, pipettes, and measuring cylinders. And then we write it down in our notes. And now we talk about what we're going to use. So to measure time, for those of you that have done physics 1.1, when it comes to measuring time, we want to use a stop clock or watch, and our units are seconds, minutes, hours, days, and years. And of course there are 60 seconds in 1 minute. What was that? Stop it. 60 seconds in 1 minute, 60 minutes in 1 hour, 24 hours in 1 day, and 360. Yeah, you should know this, but hey, gotta point it out every time. So that's for your measurement of time. Done. For temperature, our units are degrees Celsius or Kelvin. Those are two different scales. And then you've got your device, which is your thermometer or your thermocouple, which is pretty much an electric thermometer. So, which is your electric thermometer. Celsius scale, water boils at 100, and 0 is what water freezes at. While the Kelvin scale, it goes down to, it starts at 0, which is actually negative 273 Celsius. Let's see, we should talk about so your Celsius, your Kelvin, and your Fahrenheit. Please note Kelvin is not degrees Kelvin. And the way it runs is at 0 Kelvin, it is negative. Hold on, where am I to? We don't even have that on our scale. They stick to this part. At 0 degrees Celsius, it is 273 Kelvin. Do not worry about Fahrenheit at all. Doesn't matter. So that's how your Kelvin scale runs. It's still 1 to 1. But the difference is where it starts. Kelvin 0 is actually negative 273 Celsius. So your formula is going to be Celsius to Kelvin, C to K, is C plus 273. And of course vice versa. K to C is K minus 273. Those might be new formulas for some, old for others, but there you go, formulas. I'll try to make sure that I outline formulas so that you know that they're formulas. Moving right along. We move on to volume. Your units are going to be a length cubed. I guess we shouldn't say something, we should say a length. Or they can be in liters and milliliters, and there's a rumor going around that they're going to start adding decaliters, but we'll get into that if we need to. The devices that you need to measure with, the syllabus is lovely. They broke it down for you, including burettes, pipettes, and measuring cylinders. So, this device, which you will learn to love and or hate, is called a burette. And the measuring part is actually this dooflicky right here. And what it does is this tube is very long and kind of thin, so it actually doesn't hold a lot. That could be something like 2 milliliters, which is, a teaspoon of spit. And this little tap, when you turn it, it allows it to drip out 1 drop at a time. So it allows you to measure really small volumes. And if you're doing, well, you'll learn it later. When you're trying to measure acid, you can get even smaller volumes by diluting it halfway. But yeah, burettes are used to measure small volumes. Just because this tube is long, it doesn't matter. It's only about that thick, which of course isn't really going to show up on your screen. It could depend on the size. So that long thin tube doesn't hold much volume. Next we have the handy dandy pipette or pipette, whichever word you want to use. In high school, we get to use, the little eyedropper ones that you all steal and squirt each other with. Um, in sixth form and in university, you use this type of pipette. When you roll this little plunger, or you could pull it, it sucks the water up the tube. Why does it keep doing that? And it measures it that way. Also for small volumes, but to measure small volumes quickly. And last but not least, we have the handy dandy measuring cylinders. These are the ones you all are used to measuring, for measuring in the classroom. I kind of feel like I'm flogging a dead horse here. Yeah, the last way is geometric if it's given a shape, but you don't need that. Liquids and gases. Of course, if you're going to measure the volume of a gas, it really doesn't make any sense because it's going to expand to whatever container it's in, so ignore that. Boop. And boom. So again, as per usual, once you've done with your notes, you go back and you say, can I name appropriate apparatus for measurement of time? Yes. Can I name the appropriate apparatus for the measurement of temperature? Yes. Mass. Oh, I didn't do mass. See? That's why you go back and check. Boom. And last but not least, to measure masses, you use a triple beam balance or a digital scale. Amazingly, everyone knows the name triple beam balance from middle school, but when you sit one in front of the students, none of you actually know how to use it. So again, like I said in the physics video, someone needs to post me on Edmodo to remind me to put up a video of me using the triple beam balance. I'm not going to remember, trust me. Boom, and back to the syllabus. Can I name appropriate apparatus for the measurement of time, temperature, mass, volume, including burette, pipette? Yes, I can do all that. 2.1, done and done. Hopefully this one's under 6 minutes. Nailed it.